Friends, welcome to my YouTube channel. Dhanesh here. Today I am going to discuss about correlation coefficient, one of the important topic in statistics, and it is very useful for machine learning. So let's start. So before getting into this video, you need to understand two concepts in statistics. Then it would be easy for you to understand. One is covariance, another one is standard deviation. These two I have separate videos in my playlist of statistics. You can I will be giving the link in the description as well. Please watch those videos. Even though if you don't watch, it's fine. We will start. I will be giving a small idea about these two concepts as well, covariance and standard deviation. So let's start a correlation coefficient. Correlation coefficient is a statistical measure of the strength of the relationship between two variables. Variables are interrelated. For example, if you take pressure and volume, so pressure and volume, as pressure increases, volume decreases. As pressure decreases, volume increases. We will tell they are inversely proportional. For example, another two variables, if you are taking volume and temperature, as volume increases, temperature increases. Mathematically, we will tell they are directly proportional. These two are inversely proportional and these two are directly proportional. So this is the type of relationship you can define between variables. See, coming back to correlation coefficient, I will give you some more clarity on this. If you plot a relationship between volume and temperature, if two variables are directly proportional, then we can plot the graph like this. This is the graph. So here you have the data points. So I can get a graph like this. If they are inversely proportional, then you can plot when you plot the graph, you will get like this. If they are inversely proportional, if there is no relationship between these two variables, so here directly proportional, you can take it as volume and temperature. Inversely proportional, you can take it as pressure and volume. Then some variable x and y, there is no relationship, then you will get a plot like this. There is no relationship between these two variables. So what does it mean? The value of, when coming back to correlation coefficient, the most common correlation coefficient we are using is the Pearson correlation. Pearson correlation. I will give you the formula. We will discuss that as well. So first I am telling what exactly is the concept. After that we will get into the formula. So the Pearson correlation is there are different types of correlation. It is defined. The most common correlation we use is the Pearson correlation, and its value changes between this Pearson correlation. Its value changes between minus 1.0 to 1.0. It's very important. Its value changes between minus 1.0 to 1.0. A calculated number, if the Pearson correlation, when you calculate by using the formula that I will be discussing later, when you calculate the Pearson correlation, if your value is greater than, it can be greater than 1.0 or less than minus 1.0, means that there is an error. So the Pearson correlation must be between minus 1.0 and 1.0. When you calculate the Pearson correlation, if it is greater than 1.0, if R is greater than 1.0 or R is less than minus 1.0, that means there is an error in your correlation measurement. So the value of R must be between minus 1.0 to 1.0. This is very, very important. This is the first important point you need to understand. Now coming back, so you understood these three graphs as well. Now we are coming back to the graphs again. See, the correlation coefficient is denoted, as I told, it is denoted by the letter R. What exactly? It tells us how closely the data in a scatter plot fall along a straight line. So this is our plots. See how data is aligned to this graph. And if R is equal to 1 or R is equal to -1, the data is perfectly aligned. Here R is equal to 1. For this graph, R is equal to 1. This is a positive correlation. For this graph, R is equal to -1. When R is equal to 1 and R is equal to -1, here it is perfectly aligned. Here it is, the data is perfectly aligned to the plot. Here also it is perfectly aligned. If we are getting a plot like this, then the data is perfectly, our machine learning model is perfect in this case. But we won't get such perfect model. If R is equal to 0, here R is equal to 0, that means there is no relationship between the variables x and y. This is x, right? I told it is the variable we have taken as x. Here it is volume and temperature. Here it is pressure and volume. So they have a, the correlation coefficient R is equal to -1. So that point you understood. So this is the overall idea. Then I am telling, if you got R is equal to 0.2, what does it mean? When you calculated the correlation coefficient by using the formula that I am going to discuss, you got R is equal to 0.2. That means there is a positive correlation, but it is weak. If the correlation, it is positive correlation, but it is weak. There is a weak relationship between the two variables. If R is equal to -0.2, if you are getting R is equal to -0.2, there is a negative correlation, and the relationship is weak. That is, R is equal to -0.2. That's the meaning. Now again, coming back to the formula for correlation coefficient. So the most commonly used correlation coefficient is Pearson correlation coefficient. So I am going to discuss about the Pearson correlation coefficient, the formula for Pearson correlation coefficient. I told you, you want to understand covariance and standard deviation to understand it more. So what is covariance? See, covariance measures the degree to which the two variables are linearly associated. That is covariance, and covariance with the formula is covariance between two variables x and y. It is sigma xi minus xm. This is the mean value. Xi is the individual value into yi minus ym. Ym is the mean value, the whole divided by n. If it is a population, for it is sample, instead of n we will put n minus 1. There is another video, population and sample. Please watch that, then you will get a better idea of population and sample. These are all simple concepts in statistics. So this is the equation, sigma xi minus xm into yi minus ym, the whole divided by n. Xm is the mean value of the volume, and ym, here our variables are pressure and volume. So ym is the mean value of the pressure. Like that you can take it, and xi is the individual value. You can form tables and calculate these variables that we discussed in the video covariance. And in the same way, the standard deviation, it is denoted by the letter C. Standard deviation is the measure of the spread of data or variation of data from the mean. A low standard deviation means that the values are close to the mean. A high standard deviation indicates that the values are spread out over a wide range. And the standard deviation sigma is equal to sigma. This sigma is the summation. This is the standard deviation sigma. It is root of sigma I is equal to 1 to n. Then xi minus x bar the whole square, the whole divided by n. These two equations are for population. If it is for a sample, you can replace n with n minus 1. So these two are the equations for covariance and the standard deviation. Now for the equation for the Pearson correlation coefficient, it is denoted by the letter rho. For the two variables rho of x and y, it is equal to covariance between x comma y. That equation I have already told you, divided by sigma x. It is the standard deviation of x divided by sigma y. This is the equation. This is a very important equation. This is the equation for Pearson correlation coefficient. It is covariance of x, y and divided by standard deviation of x into standard deviation of y. So when you calculate using this equation only, you are getting 1, minus 1 and 0, 0.2. All these values you are getting. If it is less than, if we are getting a value greater than a calculated value greater than 1.0 or less than minus 1.0, means that there is an error in the correlation measurement. So that's what you need to understand. And another important point you need to understand here is if you are getting, for example, if you get r is equal to 0.1, then it's a positive correlation, but it is very weak. So all those aspects we covered. So that's all about correlation coefficient. Thanks for watching. Please subscribe my channel. Thanks a lot.